Hello everyone, so welcome to another episode of our Python tutorial series. In this video, I'm going to talk about the Ursina engine, 3D Python game engine, and this is going to be tutorial number 4, setting boundaries for our movement. So what we want to do, and since we are using Ursina, we want to import the Ursina module. So we could just write from Ursina import star, and we could just write app is equal to Ursina, cube is equal to entity, model is equal to cube. And now we can set the color equal to color.red, and we can just write app.run. So if I run this is just the basic example of creating a red cube. And now let's add some movement. So let's create an update function. So define update. So this update function is called once per frame, and what we could do in our update function is we could just write cube.x is equal to the previous cube.x plus time.dt. And from our last video, we learned that this will move the cube to the right. And if you want to learn about movement, you can just go back and watch my last video, which covers movement and rotation. So now you saw that the cube went to the right. And now, how do we set a boundary and make the cube stay inside the window? So let's do that right now. Inside of this update function, we could check the x-coordinate of the cube. So if cube.x is greater than 3, then I want cube.x equal to -3. So here I set the boundary for the x-coordinate equal to 3. And if I run this, we could see what happens. Now when the cube reaches this 3 on the x-coordinate, I set the x-coordinate of the cube to -3. And so that's what this if statement does. If the x-coordinate of the cube is greater than 3, I set the x-coordinate of the cube equal to -3. And so that moves the cube back. And so what if we want the cube to actually just turn around when it hits the boundary, instead of directly changing the x value? So what we could do is create a variable called speed. And so I'll create this speed variable in here, and I'll set this equal to 1. And now in our update function, I'll make this a global variable. So I'll just write global speed, and I just created the global variable. And now when I'm changing the speed here, I will multiply time.dt, or I mean changing the location. I'll multiply time.dt by the speed. And so when we want the speed to go to the right, we will have speed positive, and when we want speed to go to the left, we will change speed to be negative. And so instead of this in our if statement, we can have speed is equal to speed times -1. So now once this cube reaches 3 and it moves past 3, I will set the speed equal to the negative value of itself. And so that means it will turn to the left. And so what if it turns to the left and it reaches the -3 value? Well, then once it reaches the -3 value, I want that to also change the direction. So I could just write abs around this cube.x, and this will just check for the absolute value of the x, the cube's x-coordinate. And so whether it moves left or right, it will always change positions when it reaches one of those boundaries, which is -3 and 3. So let's see what happens. When it reaches this boundary, it bounced back, and it should bounce back again. And great, it does. So let's close this. And we can also do this with the other coordinates. So let's try this with the z-coordinate. Run this. Now you see that it looks like, from our perspective, it looks like it's getting bigger and smaller. But in reality, when it's moving forward, then it's actually just getting smaller. And when it's moving backwards, then it's getting larger. It's all perspective. Right. And so what if we wanted to add more cubes? So let me add in another cube. Let's create another variable. Speed2 is equal to 1. Let's have cube2 equal to another entity. Model is equal to cube. Let me set the color equal to color.white. This is going to be a white cube. Now let's just make a few adjustments in our update function. So we also want to add in our speed2 global variable. So we want to create a speed2 global variable. And let's revert this back to the x for our cube 1, for our initial cube. And let's create another if statement for our cube 2. But first, let's have cube 2 move in the vertical direction. So cube2.y is equal to the previous cube2.y plus time.dt. And I will multiply this by speed2. And again, I will check if the absolute value of cube2.y, if this is greater than 3, then I'll set speed2 is equal to the previous speed2 multiplied by -1. And so when cube2.y reaches one of the negative or positive 3 boundaries, it will switch directions. And so let's see what happens. Now we have two cubes. You see this white cube is moving up and down. This red cube is moving left and right. And they're just bouncing around their boundaries, bouncing off their boundaries. Alright, great. So we just did boundary checking for the cube. And this is in the space domain. We can also do this in the time domain. And we can decide after how long the cube will change moving direction. And so let's remove all this. And again, import Ursina, import star. Let's create our update function, create our base. So cube.x is equal to the previous cube.x plus time.dt. In our main, we could just write app is equal to Ursina, cube is equal to entity, model is equal to cube. And let's set the color equal to color.red. And then just write app.run. Close this. And in our update function, let's create a global variable in m. So global variable named m. Let me create m here. So m is going to be equal to 0. And what m is going to represent is that it's going to represent the current frame that we are on. And so we can have this. And after every single time this update function runs, and remember the update function runs once per frame, we want to increase m by 1. So m is equal to the previous m value plus 1. And since we want to do this on the time domain, right, we want to have a set number. So what is the range of frames at which we want our cubes to switch directions? And so let's create another variable. NumFrame is equal to 200. And this is the number of frames that the movement pattern will repeat, or the cycle of movement. So this is going to be equal to 200. Let's create another variable, and this is going to be n. And now n is going to be equal to the current frame mod the num frames. So let's say we're on frame 3, for example. Well, 3 mod 200 is still 3. But let's say we're on 203. 203 mod 200 is 3. So no matter what, we're always going to be within the range 0 to 199. And let's create an if statement. So if n is less than frame over 2, this is integer division, that's why we have two division signs, or forward slashes. And this is when n is between 0 and the 99 range. Then we want cube.x equal to, or I'll just use this. I'll just indent this. Cube.x is equal to the previous cube.x plus time.dt. Else, and this else is going to be just when n is in the range of 100 to 199. We want cube.x equal to the previous cube.x minus time.dt. And so now if I save this and run, we could see that after every 100 frames, the cube switches directions. Alright. And notice how I didn't specify a certain x-coordinate. It's based on frames. So now let's try this with rotation. So let's remove this. And let's just write cube.rotation. And I want to rotate it around the z-axis. So underscore z. is equal to the previous cube.rotation underscore z plus time dot dt multiplied by 100. So if we run this, you see that the cube is rotating around the z-axis clockwise. And so what if we want the cube to just change the direction at which it's rotating? So clockwise, then counterclockwise. Well, then using what we have learned before, let's add back in our global m. So global m, and then we want to increase the frame, and then we want to have a num frame, and this is going to be every 200 frames. We're going to create our n value, so n is equal to m mod num frame, and if n is less than num frame over 2, then, and I was going to add a note, this is going to be from range 0 to 99. Then I want cube rotation x to go clockwise. So this line right here, line 11, will make the cube move clockwise. Else, and this would be from range 100 to 199. Else I want cube.rotation z equal to the previous cube.rotation z minus time.dt multiplied by 100. And so now if I run this, every 100 frames the cube should switch directions. So let's see, minus rotation z to, okay, so this should be a lowercase z. Now if we run this, we have a cube rotating clockwise, and now it rotated counterclockwise, clockwise again. So after 100 frames, you see that the cube is changing the direction, which is great. And so this is just the end of this video. I want to thank you for watching, and I'll see you guys in the next video.